Okay, this is the second problem ever on LeetCode. It's called add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. Okay, so what I'm going to do, by the looks of it, is anytime you do like linked list adding, you need to try and think of like carryover. So like 5 plus 5 is 10, so you carry over the 1 to the next thing. So, all right. Let carry over equals 0. And then another thing is these linked lists not being the same length. That's probably the biggest issue that I'm running into, is that these linked lists are not going to be the same length. Great. So what I can do, there's like a few different strategies I have. So one is to go through each list and get the length, and then add zeros to the front based on the difference. So I could do that. Doesn't seem very efficient. And we do have a solutions tab, so we'll be able to figure out what's efficient and what isn't. Another solution I have is to run through each number, get the number, add the two together, and then just go through each place and create a new node and create a new linked list and do that, which can lead to integer overflow problems, and I don't know how time consuming that is. Yeah, you can't just assume here that they're going to be the same length, so you can't just start adding like 5 and 2, because what if it's 5, 6, and this is 2, 4, 3? That's 342. Well, maybe you can. Let's think. Maybe you can. 342, and then this would be 65. Maybe you can actually do that. Yeah, you can. Okay, never mind. So third solution would just be to add them, and then if there's no corresponding, you'll add the carryover if there is one, and then you just keep adding. You leave the nodes the way it is. Yeah, okay. So while L1 and we'll need pointers. Let pointer 1 equal L1. Let pointer 2 equal L2. Pointer 1 and pointer 2. Okay. So this is if we'll have pointer 1 dot next equals, or pointer 1 equals pointer 1 dot next, pointer 2 equals pointer 2 dot next. It's just linked list traversal there. So yeah, so this is assuming that we have two nodes here. So let temp val equal pointer 1 dot val plus pointer 2 dot val. And then if the temp val is greater than or equal to 10, temp val equals minus equals 0. It's actually 10. We're subtracting 10 from it. And then carry over equals 1. Cool. So we will add the carryover here every time, might as well. And then after this, we can set carryover equals 0. We're done adding, so there we go. Now, yep, we have all that there. Cool, so in this case, we're good. I think I will edit the first. So pointer1.val, the first equals temp val. So I'll be editing list1. So in the end, I'll be returning list1. Okay. So for this one, I think it'll work. 243, 743. I think it'll work. So let's run it. Yeah, okay. So this works for now. But yeah, there's more. So now let's do, we'll do this one last actually. We'll do this situation. So this is going to be wrong. Right, okay, so there's carry over there. So if this is 5, 5, I think it works still. Yep, okay. So we'll have carry over here and everything. Great, so actually I want to test this like so. We'll do this one first. Right, okay, so while pointer 2. So this means we have no pointer 1 anymore. Pointer 1 equals null. So we'll have to, let me think here. I'll have to keep value of the last node here. Because at this point we're checking carryover, and yeah, okay. Actually, I want to do this one. Let's do this one first. This one's easier. Okay, so if carryover equals 1, pointer 1 dot val plus plus. Cool. All right. So this is only if pointer 1 goes away, because if pointer 2 goes away, we're good. Now here, also there's potential that we need to add another. Right, okay, so, and we still have pointer 1. There's also this situation too. Yeah, I guess at this point we won't have a pointer 2, so we don't need to check that. And then here, if carryover still equals 1, we need to make a new node and keep track of the end, the last node. So this happens when This only happens when two numbers are, this is when the two linked lists are equal length, and actually not even. So this is if, because it could be 999 plus 1. Yeah, this is, we need to add a new node, basically. Need to add a new node. It's basically a new decimal place. So 1 plus 999. I need to keep track of a previous node too. So prev equals pointer 1, I guess. And in this case down here we'll have prev equals pointer 2, but we'll get to that. So prev.next equals new list node 1. So let's try that. 9 1. Cool. I want to try this actually. Ah. Okay. So if pointer 1 dot val is greater than or equal to 10, pointer 1 dot val minus equals 10, and then pointer 1. Wow, I'll need to keep going. Okay, so there we go. Okay, so okay, hold on. All right, so while pointer 1, so while we still have a pointer there, carryover equals 1. Carryover equals 1. Then we can have carryover here, 0. I can see why this is a medium problem now. Yeah, cool. And then pointer 1 equals pointer 1 dot next. And we need to keep track of our previous. Prev equals prev dot, or it's pointer 1. Pointer 1. There we go. Semicolon. Okay, let's see what this is like now. What's the problem here? Oh, I have an else if. This needs to be an if there. Whoops. Cool. So this should work for a lot of instances. Great. Okay, so we've dealt with that. Now it's dealing with if the list that we are returning becomes null. So if this is the case, okay, so this means that pointer 2, well, L2 is longer than L1. Okay, in that case, Cool, yeah, we're good with that. Awesome. All right. Now in this case, it's the opposite. It's we'll get rid of the 9s for now. We'll do 1 and 1, and then we'll do 1, 1, 1. Oh, this is gonna go forever. Whoops. Yeah, I didn't realize I had a infinite loop there. My bad. Okay, so 2, 2, and then 1. All right, so in this case, we do still have access to prev, so that's good. Now, all right, so let's think here. Okay, I know I'm going to be missing cases here. All right, so in this case, prev.next equals pointer 2. First, we got to check pointer 2. If carry over equals 1, pointer 2 dot val plus plus. If pointer 2 dot val is greater than or equal to 10, which, I mean, it only equal 10, but whatever. Pointer 2 dot val minus equals 10. Carry over equals 1. All right. So yeah, it's kind of the same thing. So if carryover equals 1, this is when we're at the end of both lists. I'll just check this one. Let's see. Okay, still wrong. Prev.next equals pointer 2. It's interesting that this is not working. Oh, this is because, oh, gotcha. Okay, why don't we do this? And then we'll also need I'm trying to think here. It's sort of the same thing. We're kind of continuing the same thing up here. Yeah, we're kind of just continuing the same thing up here. So this might be good, actually. I don't think we need the carryover thing there. Okay, so yeah, it's good for that case. What about if these are just 9s? And we have 1, 1 here. Then what happens? Thought so. Okay. Prev.next equals pointer 2. Pointer 2 should have... So this is 10, the carryover, boom, carryover. Prev.next, which is pointer 1 in this case, equals pointer 2. Pointer 2 equals pointer 2.next. Okay, so what is pointer 2 here? I just want to see. What do we got? Yeah, it's a list node. Zero. Oh, I'm not setting the previous. Oh shit, okay, hold on. I think I know what's up here. Oops, sorry. I think I know what's up here. Dude, this is a really tough problem, actually. So I basically need to switch here. So I need like a count value as well. Like if we're on the first previous pointer 1, so let me think here. Okay, so in this situation, if old prev equals true, we'll do prev equals pointer 2, else it's prev.next equals pointer 2, else prev equals pointer 2, I think. We could check this in the beginning. Yeah, it's probably smart. And then I need to also old prev equals false after that. Okay, let me just see if this works. Yeah, okay, cool. That worked. So we just connect them and then just start working again. All right. Probably do this outside of the loop too, but it's fine. What else? What else could happen? Like 23, and then we have this. We don't even need a 9 there. 3, 5, or 3, 7, 5, something like that. 506. I guess this is working. Submit. There's probably something I'm missing. No, I got it. Okay, cool. Apparently it's using a lot of memory, but yeah. Try one more time. I doubt it'll be much better. Okay. Never mind, it has perfect runtime now. Yeah, it's weird. I guess I have too many pointers, carryover, all that. I'm gonna check the solution though. This was a bit complicated. There were a lot of things to keep track of. Doing this in an interview would be kind of nuts, but okay. Elementary math. Hey, that's kind of what I did. Oh, that's all it is. It's just elementary math. All right. Anyways, yeah, I guess I got it. I guess this is good enough. I have a feeling this won't be asked at an interview. There's not a whole lot to lead up to this. How many loops do they have? P and Q, L1, L2, carry. All right, well, I'll consider that solved. Anyways, solved correctly. Didn't seem too hard. So there you go. Thanks for watching.